Okay, I think I have another 30 minutes to try to figure this out. I spent some kind of off-hour brain thoughts on this. I think I was pretty close in interpreting after creating the streak counts array, streak counts being the streak of ones and zeros and ones and zeros and ones and zeros, how to parse that. So I think it should be based on based on processing processing two streaks at once, the ones and the zero streaks. And basically, if there's a streak of ones, then if there's a streak of ones, like there's one one or two ones or three ones, what happens is it makes the next streak of zero convert into a single one in the least significant bit. Since so in the rightmost bit, it converts that zero into a one, and then it kind of gets rid of it. So using n plus 1 operations where n is the length of the streak. So if there's a streak of 1, 1, then using two 1 plus 1 operations, it converts the rightmost 0 into a 1. If it was two ones, then it uses three operations to convert the rightmost 0 into 1 of the next streak. So I'm going to process every two streaks. So while length of streak counts is greater than 1, which means it's going to be an odd number, only odd length of streaks here. Since it was even, it removes 1. So if it's odd, then answer plus equals the last streak on the right, length, streak counts, the last one plus 1. And then from there, it's going to use two operations to kind of move the 1 over. So for instance, if there was three zeros here, it uses two operations to remove over the remaining, let's say examples. So it uses three operations to make this 0 into a 1 and kind of get rid of this other stuff. And then the remaining zeros, it's going to use two operations per to move this 1 over to the left. So it's going to be answer plus equals streak counts, the number of zeros minus 1 times 2. So it could be just times 2 minus 1 times 2. Minus 1 because one of the zeros already converted into a 1. And then I pop those two off of the stack. And then whatever's on the last one, now there's going to be an extra streak. So it's going to be plus equals 1. And then that gives me the final streak, and if the final streak is anything more than 1, then it does the regular operation to convert a bunch of ones into a single one. I think this should work. Wow, kind of slow, huh? So there was a bit of handling of streaks here that maybe I can combine into a single handler. So if I didn't have an array of streaks, I didn't have to try to count all this stuff. Guess I could probably parse it back from right to left. Probably parse it right to left. Does that work? So if I try, let me try it one more time, see if it's any randomly faster. Probably. Okay. I just hate Python. Or hate Leetcode's test case runtime shit. Okay. I guess that's good enough. One random 100% is good enough. So that wasn't true. I think there was probably a better way of counting streaks than this. Every bit, so just converting it. Guess this is probably fine. Yeah, I guess it's probably fine. Okay, remove ending 0 bits. Yeah, it's fine. And then I think that's fine as well. All right, so I guess the summary of what happens here in terms of just an example. Let's say it's 1 1 0 3 zeros 1 0. Okay, so this means that the streak counts array would be 2 1s followed by 3 zeros, 1 1, 1 0, 3 1s, 2 zeros. So in terms of the counter for the number of operations, so the answer is initially going to say that there's going to be 2 operations to remove the last 2 because there's an even number of streaks, so that means that the last streak has to be a streak of 0 bits. So it's going to be 2, and then the streaks will be now 2 3 1 1 3 3. And then what the process is, it's going to look at every 2 blocks, the streak of zeros and the streak of ones at the far right, and the streak of ones will convert. So what this is right here is right now it's a 0 and 3 1s, right? Is be that last chunk. And what's going to happen is it's going to take 4 operations for these 3 1s to convert into a single 1. Actually, maybe I can modify this. Say there's 2 zeros at that spot. So it converts the leftmost 0, sorry, the rightmost 0 here into a single 1 due to the carryover effect, like adding 1 to this thing plus removing 3 zeros on the right. And then what would happen is it will take, for each 0 that's left over in that streak, it'll take 2 operations to move this 1 over to the next slot. So it'll take like because there's only one left, it's going to take another 2 operations. So the answer is equal to 3 plus 1 is 4 plus 2 is 6 plus 2 is 8. So 2 plus 4, 4 for converting these ones, and then another 2 converting this 0. But now the streaks is now actually 2, 3, no, 2, 4. 2, 4, 2. So 2, 3, sorry, 2, 3, 2. Because what that means is it moves this right side to have another 1 next to this 1. Yeah, so then the left side is now 3 zeros followed by 2 1s. And it'll take 3 to do this, to convert it into like that, and then another 4 to move the 1 over to the left. So that's 3 plus 4 is 7, so answer is going to be added by 7, so it's going to be 15. And at that point, streaks is now 3, because it made this last one a streak of 3 1s. So on the right 3 means, on the left 3 means that it's going to take 4 operations to do that. So answer should equal 19. So just double checking that process. Test case. Yeah, answer is 19. Okay. Anyways, that's the general process, and then this is the code for it. Find your streak counts, and then like removing the even streak at the right, or the rightmost streak if it's an even number of streaks, and then kind of working on every 2 cycle. So summary, pretty kind of complicated process to explain how I logicked it. But the work is like above. Whatever solution for this probably needs to not try to perform actual binary operations, I think. Operations, but to find some simplification of the underlying kind of bit logic or bit math. I used something that relied on looking at the streaks, oh my god, of 1s and 0s, and kind of simulating the number of operations to work with those streaks. Time complexity can be O of n to convert or to iterate over the bits of the string to determine the streaks, and also to iterate over the streaks array to determine the overall answer count of operations. Space complexity can be O of n to store the streaks array. I believe there should be a solution that is O of 1 where the streaks array is not used, but the count is uh, calculated